Moving further, we are now into the details of 3-point estimates or a PERT. You can say a triangular distribution or linear distribution or a beta distribution. The point here is, again, you need to understand that these 3-point estimates, earned value management, bottom up, you cannot do first. You cannot have a full power and the usage of it until and unless you have a very good work breakdown structure defined for your project, because they all depends on a work package level. They all work on a work package level. They identify that how all the deliverables will sum up to and then you have a whole project timeline. So this is where you will be actually linking every single estimate to the work package level, and then it will help you identify the risk of why this specific deliverable is identify the reason why this specific deliverable is at risk. This is where it comes. So we are technique used to estimate cost or duration, cost and duration both, by applying an average or a weighted average. So we have two formulas. One is called triangular distribution or a linear distribution, where we will take the pessimistic, most likely, and optimistic and will divide it by 3. In this, when you are talking of a triangular distribution, it does take risk and uncertainty in account, but it is saying that the weightage of a risk and uncertainty, which is optimistic and a pessimistic, is same as what the most likely is. So it becomes a triangular distribution or a linear distribution. On the other hand, when you are talking of a normal distribution or a non-linear distribution or a beta distribution, we are actually saying that our formula is based on one or optimistic, one of pessimistic into 4 of most likely. What we are saying that there are 60% chances on a project that we will be delivering a project on time. So we divide 100 in terms of 6, which is almost, let's say, 18 or 16, and then most likely is 4 times higher than optimistic and pessimistic. So because we are an expert, we have given you the timeline, so we are sure about that if these things would not go wrong, the plan that we have given you is the most optimistic plan, which is a most likely. So the formula, which is a beta distribution, is CO plus 4CM plus CP divided by 6. So in this case, 1 of risk into 4 and 4 of most likely attitude. So you need to identify the create work breakdown structure. This is the basis for any proper estimation, which will tell you that how much time you actually need on the project. And this is where the progressive elaboration and the rolling wave plan comes in, that you don't know about your project from day one. So you need to wait for a little bit. Then you have to go near future and far future, near future and far future. I'm sure you remember that diagram of current, near future and far future, that how you need to move in terms of rolling wave plan. So interview, brainstorm how best we can do the job. Then ask what kind of a risk associated with this and what could go wrong, which is a pessimistic. Grill down the idea of nothing would go wrong. Nothing would go wrong definitely does not mean that nothing else absolutely would go wrong. You go straight a highway on a very fast lane. No, there is something will happen. There's something which is not but most likely, but it is most optimistic that could happen. Then calculate the single 3-point estimate using the calculation. So most likely, pessimistic and optimistic, and then divide the PERT formula or a beta distribution. This will give you the idea behind, this will give you the calculated buffer. So if we go further, it will give us the distribution of a beta distribution, which if you could see that starting with the shorter, then you have a most likely used in original CPM calculation, which is actually a PERT. A little bit next is a PERT, which is optimistic plus 4 most likely into pessimistic plus pessimistic divided by 6. And then we are saying optimistic and pessimistic are two extremes. We would like to go in between the whole concept. We would like to stay in between that. Sometime it is, if most likely is 4 for 1, we either able to finish in 3.8 or 4.2. We don't want to go into the optimistic, which is 3, and which is, if we don't want to either go into the pessimistic, which is 7. Two important points to remember. If you have identified your estimation in terms of optimistic, most likely, and pessimistic, and all your results in actual, when you are doing a variance analysis, when you are collecting the data as a data information, and most of the data point that you have collected against every activity is falling between most likely and optimistic. So you could say between optimistic and most likely. Optimistic and most likely. So optimistic, most likely, and pessimistic, 3 columns. So optimistic and most likely, it means you have already padded the estimation. As a normal human being, we would like to live in the normal distribution, a beta distribution, or a bell curve, where actually we say that yes, sometime we will be a little bit early, sometime we will be a little bit late. If most of the data points, most of the activities are finishing in a real time between most optimistic and the most likely, it means you have already padded the activity unnaturally without identifying the risk. Second point, if most of your data points in terms of actual data collection is between most likely and a pessimistic, it means your initial assumptions were wrong, your most likely is wrong. You might need to go back and reevaluate, because it could not happen that you are already going always in this range of most likely pessimistic. This could happen for multiple reasons. Once, either your estimations are wrong, or you might need to reevaluate that, or you were pushed to give the most likely estimate just to save your bag, or to present in this, yes, and most likely we will finish in 15 days, but if something would go wrong, we will go into the 25 days. So these could be the reasons.